Il s'agit de l'hydrogène vert. Ces thématiques revêtent une grande importance dans le contexte actuel, comme vous le savez, où la transition vers une économie plus durable et respectueuse de l'environnement est devenue vraiment une priorité mondiale. C'est un domaine en pleine expansion qui suscite un intérêt croissant dans le monde entier. Nous allons essayer d'aborder le maximum de points durant le temps que nous aurons ensemble. Nous vous présenterons les objectifs de ce programme de formation ainsi que les différents modules qui ont été conçus pour vous offrir une expérience d'apprentissage complète et approfondie. Nous vous donnerons également un aperçu sur les formateurs qui seront impliqués dans le programme, tout experts dans leur domaine respectif. Et nous vous encourageons bien sûr à poser toutes les questions que vous pourriez avoir tout au long du webinaire et nous ferons de notre mieux pour y répondre de manière claire et très précise. Donc, sans plus tarder, nous avons l'honneur d'avoir avec nous aujourd'hui professeur Samad El-Fayed, professeur titulaire à l'UM6P et directeur de l'IM7, laboratoire des matériaux inorganiques pour les technologies énergétiques durables. Sans plus tarder, je cède la parole à notre invité d'honneur qui est avec nous aujourd'hui. Samad, bonjour.
Ok, bonjour Kaussal, merci beaucoup pour cette présentation. Je vais passer à l'anglais comme il y a des gens qui sont anglophones connectés avec nous. The objective of the webinar of this afternoon is to give you the details about the executive master that we are launching now about green hydrogen and its application. Just I will start by a small introduction. When we are speaking about green hydrogen, we have, sorry, when there are some noises, okay, please, if you can switch off your microphone. When we are speaking about green hydrogen, we are not speaking just about the production of hydrogen, but we are speaking about all a value chain. In this case, we have like what we call the feedstock. That means what kind of elements that we need to produce this green hydrogen or green molecule in general, like the use of renewable energy with the storage of the energy, the green water that we need also as well for the production of green hydrogen, the CO2 capture that we need also to produce some molecules that we will speak later. And in the case of the production of hydrogen, also, when we are speaking about the production of hydrogen, we have different kinds of methods. The famous one that most of you may know is the electrolysis. That means we use electricity to split the molecule of the water to produce hydrogen and oxygen. But we have other kinds of technologies, as we call them emerging technologies, like the thermolysis that we use just thermally driven process to produce green hydrogen, or photolysis, or the production of hydrogen via the biomass. In the case of the conversion of this hydrogen to other molecules, we can convert it, as you know, to green molecules like the green ammonia that normally we are using in fertilizers. But from the hydrogen, the green one, with the CO2 that we can capture from different industrial processes that they are emitting CO2, or also from the atmosphere, we can arrive to produce what we call green ethanol or green methanol, or we can also prepare all kinds of e-fuels that we can find nowadays in the market. In the case of the storage, also the handling of the hydrogen, we have also the storage of the hydrogen, how to transport it, because you hear lots here in Morocco that wants to produce green hydrogen, but we need to export it to the off-taker. That means in Europe, that, for example, if we have like client there, how to transport this hydrogen from Morocco to Europe, and also how to handle this hydrogen inside of the Moroccan territory or inside the factory, with all that corresponding to the safety and other aspects. After that, this hydrogen can be used in different forms, not just hydrogen, but green molecules can be used in fuel cells, for example, to produce electricity. Again, that means we have in the first step, we prepare hydrogen, but if we need electricity, we can use this one in fossil fuels, and we can generate electricity that can be used for different purposes, like the case of hydrogen cars or hydrogen vehicles, where we have a fuel cell with an electrical engine that can drive these vehicles. That means in this case, we use the hydrogen as fuel. We can also have an internal combustion of hydrogen to produce some mechanical energy that also can be used in transportation in vehicles for in transportation. But also we can also make a combustion of the hydrogen to produce heat. And for the utilization, the case that we have nowadays in the market is to use hydrogen to produce ammonia for fertilizers. We can use this hydrogen in iron steel industry and also in petroleum refining and other kind of industries. When we are speaking about all these technologies, we have some of them are in the markets, are already commercial, but we have other ones, like if we are speaking about thermolysis or photolysis, we still have them at laboratory scale or in the under developments. If we see what is the situation now of hydrogen in general, what we have now in the market, we are producing more than 96 million tons per year of hydrogen, but big part of this one, more than 99%, is produced in forms that we call them not clean process. Why? Because in parallel with the production of hydrogen, we are producing lots of gases are responsible of emissions worldwide. And this hydrogen, we call it unclean hydrogen. And what is the utilization of this hydrogen nowadays? We are speaking about 55% of this hydrogen produced worldwide are going to produce ammonia. 25% is used in petroleum refining. We have 10% is used for methanol production, and just 10% is used for other applications like steel production, fuel, and food. But if we see the expectation that you see here in the right side with the development of clean hydrogen or green hydrogen, you see that the expectation that nowadays in 2020, the consumption of hydrogen was around 70 exajoule worldwide. But if we see in 2050, the expectation to have more than 500, almost 40 exajoule. That means you can see here that we are 8 times higher. And what we are producing nowadays, 70 exajoule, the double of it should be used just for transportation, like in this case. That means in 2050, we are looking that this hydrogen will not be used just for this kind of applications, but also will be used for transportation, for power generation and buffering, for industrial energy, for welding, heat and power, and for other kind of applications. Where we can apply hydrogen. Here, this graph is showing, okay, that we can apply hydrogen as feedstock. This is like for different chemical industries, like in the case of fertilizer or hydrogenation, hydrocracking, desulfurization. But we can also use this hydrogen to produce fuels in general that can be used. But in this case, we have also a competition between this hydrogen that should be used for this kind of application with other kind of biomass and biogas. But also we can use hydrogen for producing electricity for transportation in vehicles, like the case of train, even aviation and other kind of application. But we have competition always, like the case nowadays, between the electrical cars based on batteries and electrical cars based on fuel cell using hydrogen. That means always we have the question of cost and competitiveness. This is the reason that why in this scale we are showing like this application that's in the upper part are unavoidable. That means we should use just hydrogen, but here is depend of the competitiveness of the solution that we have in the market, and we know that even that these two fields using hydrogen or electricity, both of them are under development. That means if we develop more hydrogen, we'll have more penetration in the market. If we return back to the ways how we are producing hydrogen, before I showed you that we have like unclean hydrogen, what we are producing nowadays, like green hydrogen, gray hydrogen or blue hydrogen, or clean hydrogen, that's what we call green, or even other kind of colors that we'll discuss after. And here in the case of unclean hydrogen, we have is based on fossil fuels. That means we use hydrocarbon reforming or hydrocarbon pyrolysis. And in this case of hydrocarbon reforming, we have different processes like steam reforming, partial oxidation, autothermal reforming. But in all this kind of the process, we are using fossil fuels. That means we are using petrol, we are using natural gas, we are using other kind of fuel to arrive to produce hydrogen. But in parallel of that, we are producing a big quantity of CO2 and other gases. In the case of green process, we use just renewable sources. We can have different kind of processes like biomass processes with biological or thermochemical, but we have the famous process that's what we call water splitting. And even in water splitting, we have different technologies or different processes like electrolysis, thermolysis, photolysis. And even in electrolysis, I guess that some of you are famous with this field. We have different kind of technologies like alkaline technology, proton exchange membrane technology, SOIC technology, or IOM technology. That means even in these ones, we have difference of technology. You see here that we have a different process methods to produce the unclean hydrogen or clean hydrogen. And from there is coming the coloration that we have nowadays for hydrogen. And here just I'm giving you the example of what we should look for to classify this hydrogen. We should look for feedstock, the production process, the source of energy that we are using to give classification. If we want to have green hydrogen, that means we use here water, we use the electrolysis process, and we should be fed by electricity generated from renewables to arrive to have a level of green hydrogen. But if we use the same process, for example, water with electrolysis, but is powered by nuclear energy, in this case, we call it pink hydrogen. Or if it's powered by fossil fuel or electricity generated by fossil fuel, in this case, even that we cannot speak about green or pink, but we should speak about blue and gray. But now I think the market is going beyond this color classification, and we need to develop or is under development to have international hydrogen classification system. That means we have what is black, what is green, and here we should just check what is the greenhouse gas footprint for this process. That means we should calculate what is the green gas footprint for each process. And based on that, we label the hydrogen that will be produced in the future. But to arrive to develop green hydrogen economy, we have several challenges. We don't have time today to speak about all these kind of challenges. But first of thing, we need to have source of energy, renewable energy, solar or wind. And just I'm showing these ones to tell you that here in Morocco, for example, or Africa, we have a great potential for solar irradiation and also for wind power. That means here we have the resources that will allow us to produce the electricity from renewables that can help us to develop green hydrogen economy. For the water, as I explained, that's one of the process or the water splitting processes that we are using electrolysis, thermolysis, and other process. We need to have water. And as you see that the water nowadays, we have a big problems in Africa and even in all the world. That means we should to look for other source of green water, like the case of the desalination of the seawater. That's something we should promote with the production of green hydrogen. And here I am giving you just this graph because sometimes when we hear what is the quantity of hydrogen that we need, the people that sometimes they are thinking that will be a huge quantity. But if we are looking for the expectation I showed you before, in 2050, we will need around 24.8 billion cubic meter. If we compare this one with the current situation of the use of the water that you can see here, just for industrial process nowadays, we are using worldwide more than 768 billion cubic meters. That means here is just a small fraction that we are using for water to generate the hydrogen that we will need in 2050, according to the expectation I showed you in the slides before. And also the costs. If we are speaking about the cost of the production of gray hydrogen, blue hydrogen are now competitive compared to the green hydrogen. That means if we want to develop green hydrogen, we need to decrease costs. How we can decrease costs is research and development. That means we should promote more research and development to increase the efficiency of the process that we have nowadays in the markets, or to develop new technologies that will allow us to produce hydrogen with low cost. The second, the other main challenge is the manufacturing of all the components that we will need for this hydrogen economy. If you see here, this is the world map, you see the companies that we have before, you can find that we have companies that are producing, for example, the electrolyzer, that is the main component for the production of green hydrogen. You find them in Germany, a lot of companies, UK, France, Norway, in all Europe, China, we have lots, we have in US, Canada, but unfortunately in Africa, we don't have any company. That means also this is one challenge to develop this technology here in Africa. And you heard like in last February, John Cochrane is from Belgium, they were signed agreements to produce this electrolyzer in Morocco. And from there is coming our attention at the university that we need to prepare the people or the leaders or the experts that they are going to work in this field of green hydrogen economy, not just the production of green hydrogen, but all green hydrogen economy. And this is like the first step of this executive master. Of course, we are designing other kind of formation at the university that will be launched very soon. But as first step, as fourth pillar of this kind of formation, we launched this executive master in green hydrogen and its application. And the main goal of this executive master is to prepare industry leader for the emerging field, covering the fundamental productions, storage, transportation, safety, regulation, and business strategy. And later on, we will see what is the importance of each part of these components. Now I will just give you a brief description of each model that we will have in this executive master, and later on at the end I will give you a summary. The first model, as I showed you before, that nowadays we are producing the hydrogen mainly by a process that are responsible of the contamination of the globe. That means we are using process that, because are very competitive, we are using process where we are using fossil fuels to prepare hydrogen, but in parallel, we are producing lots of CO2 that are emitted to the atmosphere. Just to give you a very simple idea, by this kind of process, if we take steam methane reforming, that is responsible, that is having the less footprint of the emission of the CO2, for each kilogram of hydrogen, we are producing in parallel more or less 13 kilograms of CO2. That means the quantity of CO2 that we are producing is huge. But for us, we need to learn. We need to know how we are producing this one. This is why this model will give us a general overview about all the process that nowadays we are using at industrial scale to produce the hydrogen. What is their advantage, their drawbacks, and how, even that we have some ideas how to decarbonize this kind of process. Also, we will have an overview about the methods that the people are trying or the researchers are trying to decarbonize this kind of process. And as case study, we will study what is the environmental impact of this classical process that we are using nowadays in industry, and how we can decarbonize them, and also to show what is the advantage of developing a green hydrogen molecule instead of going for other colors. For the second model is about green hydrogen production technology and emerging options. As I presented to you before, when we are speaking about green hydrogen, all the persons are thinking about electrolysis. Electrolysis is just one process. That means we are using electrolysis. We use electricity to split the molecule of the water, and we can develop this kind of technology based on different kind of mechanisms. And this is what we call them like different kind of technologies: alkaline technology, PM technology, SOIC, and IAM. But we have other kind of technologies that also allow us to produce green hydrogen, like biomass, or as I told you before, is the thermolysis, that we can split the molecule of the water based on thermal driving process. That means we use just heat to split the molecule of the water and to produce hydrogen and oxygen. And this is the aim of this model. Okay, we are going to speak about what is the matter technologies that we have nowadays in the market concerning the production of green hydrogen, and what are the emerging options or the ideas are under development to produce in the future the green hydrogen with competitive prices. And as tutorial for this model, we will do a tutorial on PEM and alkaline electrolyzers. Why we choose this case study? Because in George very soon we'll have 2 pilots at pre-industrial scale running with this kind of electrolyzers, and this will allow us to do a real comparison between these 2 technologies that are operating under the same conditions. And even here at the university in the campus of Ben Guerir, we have a smaller electrolyzers that are dedicated for research and also to promote the hydrogen mobility in the campus. And also this kind of electrolysis will be used as case study or tutorials to show what is the advantage, disadvantage of each one of these kind of technologies. Concerning the model 3, this is the technical option for handling, storing, and transporting hydrogen. These are very, very important issue, because even that if we produce hydrogen, the hydrogen that we produce, we need to store it in adequate form and also transport it from the site of the production to the site where we have the end user. And this also is not easy task. This also, there are a lot of debate on that, how we can transport it in form of hydrogen complete form via pipelines or via other molecules that also ammonia is considered as medium to transport hydrogen. We have lots of technologies, lots of techniques that we want to show you in this case, in this model, to show you what is the advantage, disadvantage, what kind of technologies that we can use nowadays, and one kind of technologies that we can use in the future. And as a case study here in the laboratory, we are working on solid storage of hydrogen in solid form. And we are constructing a pilot at laboratory scale, and wants to show you here what we are learning from this kind of developments, how we can store hydrogen in solid form, how we can operate it, how we can charge the system, how we can discharge it, what is the advantage of this technology compared to other battery technologies that we have in the market, like the compressed storage or liquefied storage. In the case of the model 4 is green molecule synthesis and green ammonia. This model will have a focus how to synthesize other green molecules, not just the ammonia. Like in the case of the ammonia, we need to have green hydrogen and we need to have nitrogen that we separate from the air. That means from nitrogen, hydrogen, we can synthesize green ammonia. This is the pilot. Also, we have a pilot that will be constructed in George. But apart of that, we can use also the CO2 from decapitation to associate with hydrogen and to prepare different kind of e-fuels or e-molecules. This in general. And the tutorial that we want to give in this case of model is the tutorial on Haber-Bosch process. We have here at the laboratory with our partner at the M6P, a small Haber-Bosch process that's there you can learn how we can make the synthesis of the ammonia at laboratory scale. That means we have just source of hydrogen, nitrogen, what kind of condition we should deal with them, what kind of catalysis, what is the advantage of each kind of catalyst, disadvantage, and to compare them in real case, and to have at the end to learn how we can synthesize this kind of molecule at laboratory scale. For the 5th model about fuel cells and their application in transportation, power generation, and industry, as I explained before, if we have the hydrogen, we can associate it with oxygen via fuel cells to produce electricity and steam as byproduct. That means just associating hydrogen and oxygen via catalytic process and to produce electricity. These technologies having more advantage compared to internal combustion of hydrogen because it's having higher efficiency, and also the process is green. Why? Because we are associating just hydrogen with oxygen to produce steam and to generate electricity. In the internal combustion of hydrogen, we should be careful, because if we are using the air, we have also the risk to produce NOx gases apart of producing electricity. This is the reason why this technology is having more advantage in the sense of efficiency and also maintaining all the process green. And as case study here, we are going to study the fuel cells application in mobility. As I explained before, we have even that fuel cells that we are going to use them at the laboratory scale, small scale, to check what is their performance and so on. But also we are going to compare what is the advantage of using fuel cell or battery in mobility as a case study. The model 6 is related with safety. regulatory and environmental consideration. As you know, the hydrogen is like new things that we are dealing with it in our industry. What kind of measurements of safety that we should take in consideration? The regulatory to have like a how we can use this hydrogen, and also environmental consideration. This is what also we explained before. But as case study, we should also in our industry, we are looking to innovate. Okay, that's what means innovation, to adopt new technologies related with hydrogen. But associated with these new technologies, we have some risk. That means in this case, we should have how we calculate the balance between safety and innovation and how we can integrate them in our industry. And for the seventh model is about business method, policy, and strategy for developing a hydrogen economy. As I explained before, the hydrogen is different to renewable energy, for example. Renewable, just you produce electricity and you should have off-takers. But here, in the case of the hydrogen, if we are producing hydrogen, we can develop all the value chain. We can develop new products. We can develop new processes. That means is a complete as a different case to the other one. We can speak about not just making a site of production, but developing factories. And from there was coming the idea of the case study, how we can develop a hydrogen factory business plan. That means from the scratch, how we can do and how we can see that the factory that we are going to develop, we will have some return and we can create a successful business case. And for the model 8 is about the master final projects, and normally the participants in this master, they should apply all the expertise that they receive during this formation and how they can apply it in the industry or in the process that they are responsible for it in their industry. That means should be applied case. Of course, here we will the persons that will take this kind of case study will have the support of the experts of these executive masters during the whole year. And as summary, here we can see that we have more or less 5 technical models. The first one about the fundamental of hydrogen technology and production process. The other ones is about the green hydrogen production technology and emerging options, technical options for handling, storing, and transporting hydrogen, the green molecule synthesis and green ammonia, fuel cell and their application in transportation, power generation, and industry. We'll have a model about the safety, regulatory, and environmental consideration for hydrogen technologies. We have a model that is related with business method, policy, and strategy for developing a hydrogen economy. We have the master final project that also should be developed. And of course, we'll have a learning expedition to hydrogen platform in Europe. That means the participants can participate to go to the Europe and to see the good practices that normally they are using in this case of developing a green hydrogen economy. This is the website that you will receive an email after that. You will find all the information about the master, the main information, and also how you can apply to this master. And for the plan of this master, we are speaking that the language should be in English and French, because both of them, but in some cases it depends on the expert that we are going to hire, or the experts from the university that they will participate with us in this executive master. Sometimes we find experts that they are not speaking French. That means by obligation we should guarantee English, but some cases will be also in French. The attendance will be a mandatory lecture, can be in hybrid mode sometimes if the person cannot be here in place. That means normally we prefer that the person can participate physically, but in case that there are something that will not allow the participant needs to be physically here, at this case can participate online. Regarding the location, we are speaking about Benguerir, Marrakesh, Jorsfar to do some tutorials, maybe Rabat, because we have Africa Business School are involved also with us in this in one model, and also the expedition to a platform in Europe. That means also part of this formation will be in Europe. Regarding the eligibility, this program is open to both Moroccan and international candidates. The candidate should hold a bachelor degree in engineering or related field. Work experience in the field of energy is a plus, but is not mandatory. Technical backgrounds in chemistry or physics is encouraged. That means it's not by obligation that the person should have. And a minimum 2 years of work experience is required. And here, this is what we mentioned before, at least the candidate should follow the courses in English. That's all from my side, and I'm waiting for your questions.
Thank you so much for your intervention. We are here to answer all your questions. Don't hesitate to ask your questions in the chat. Nous sommes là pour répondre à l'ensemble de vos questions. N'hésitez pas à poser vos questions sur le chat ou bien prendre la parole. Information session that reflects our knowledge. Thank you, Professor. Thank you, thank you. Nous sommes là pour répondre à l'ensemble de vos questions. N'hésitez pas à poser vos questions. J'espère que ça a été clair et très précis pour vous. Il y a une personne qui questionne sur le prix du master à distance. Certes, Samad, normalement,
For me today, I will not speak about the price of the master, because we have the department of the executive master that is in communication with the participants about these aspects. Please just write email to the persons and they will answer to your question. For me today, I want more or less to discuss about the technical offer that we are offering in this master. Thank you.
Thank you for your intervention. Il existe déjà notre adresse mail. Comme ça, si vous avez d'autres questions, vous pouvez nous envoyer, on vous répond, bien sûr. Est-ce que tout est clair pour vous? Vous n'avez aucune question, aucune proposition, suggestion? Si vous me le permettez, moi,
Yes.
il y a une question déjà. Could you please precise the part-time period?
Yes, I will answer to this question. Normally, as I showed to you, the master is formed by 8 modules, a part of the expedition learning to Europe. These 8 modules, for each one of them, normally the duration is will be 1 week in 1 month. That means, okay, for example, you can imagine that we will start our model in October. That means the first model will be in the mid of October, taking 1 week. And so on. That means we will agree with the participants, with all participants, but also we should guarantee the availability of the experts. But in general, at the mid of each month, we will have 1 week dedicated to have this master, that the persons should be physically with us. But in case that is not possible, at this case, we accept that the person can participate online.
Please, can you share with us the presentation and thank you? Yes, on va partager avec vous, bien sûr.
We will share with all of you the presentation. I will send it to Kautar and she will take in charge to forward to you. We have here a question about how much is the cost difference between green hydrogen and normal hydrogen production. This is a very, very good question. The normal hydrogen, if we are speaking just roughly, we can speak that the normal hydrogen is 1.5, is the gray hydrogen dollars. With the blue hydrogen, the cost is increasing to more than 2. But if we are speaking about the green hydrogen, the price nowadays is almost the double. But they are the target worldwide to promote research education in order to decrease the cost of the production of green hydrogen. And the last number was coming from the DOE is to reach very soon $1 per kilogram, and in this case, even that the production of green hydrogen will be more competitive compared to gray and blue hydrogen. That means without even contaminating, we can produce hydrogen with a lower cost compared to the gray and blue hydrogen.
Okay, thank you.
Thank you.
Engineer OCP can participate in this master? If yes, what is the conditions?
Yeah, you are eligible to participate. I think there is no condition. The condition that we told just to have a bachelor degree and 2 years experience in the industry, and you can apply for the master. But yeah, you are eligible. We have other question: how much kilowatts required per kilogram of hydrogen? More or less, we are speaking about 50 kilowatts hour if we are using electrolysis. But this, of course, is depend of what technology that we are using. As I explained before, we have alkaline, we have POM, we have other ones under development like SOIC, IOM. But in the case of alkaline POM, also if depend of the provider of each technology is depend of the catalyst that is using inside of this electrolyzer, you will have a difference between the what's the energy required to produce 1 kilogram of the hydrogen, and this is related with the efficiency of the electrolyzer. But all these details you will receive it in this master. That means our aim that if you attend to this master, you will learn how normally we can calculate the quantity of the energy that is required for hydrogen production, and what is the parameter that are affecting the efficiency of the technology that we have in the market. And from there, you can more or less you estimate what the interval of this energy.
Il existe une autre question de la part de Mehdi. S'il vous plaît, est-ce que l'industrie de production de l'hydrogène nécessite l'utilisation des terres rares à l'instar du solaire et l'éolienne?
Yes, of course. It's not the rare earths, but in the case of the electrolyzers, for example, if we are speaking about the electrolyzers, we have 2 types of electrolyzers. We have that is matter technology, alkaline and POM. In the case of the alkaline, we are using nickel-based metals as catalyst. But in the case of the POM technology that is having higher efficiency, we are using noble metals like platinum, ruthenium. These are other questions. This is the reason why normally the POM technology now is more expensive than alkaline technology. And this is the reason that there are a lot of research to try to decrease the quantity of the catalyst that we need for the process. And from there also is coming the need to develop new technologies like solid oxide electrolyzer technology, that we are using oxides, not metals, not noble metals, and also the water splitting the technology at high temperature, we are using oxide. That means the aim in the future to arrive to decrease the cost is to not use noble metals and not to use, in this case, we are not using rare earths, but to not use even these expensive metals.
Thank you. The training program includes quality monitoring and control or not?
Of course. This is of course, this is something that is mandatory that we have here at the university. We should include these parameters, and of course, for the masters, we will have like some kind of evaluation, and because at the end we will deliver a diploma degree that is signed by the university, and we should maintain the quality of the diploma that we are delivering.
Okay, thank you. Are you using DFT calculation to do so?
Of course, in all the models, you will have part of the simulations. I can give you just an example, for example, of the storage of the hydrogen, that you can have DFT, or even in the case of the electrolysis, you will have some models dealing with the modelization. That means in each part of the program that I was not providing details, what kind of element that will be included in each model, but I will send you the presentation. You will find the main or the key elements that will be targeted by each model, and you will have some parts related with the DFT calculation.
Is the 2 years experience mandatory and what educational background is privileged?
2 years, yes, this is what we agree with internally to have at least 2 years of experience. And the background we are speaking about bachelor, as I explained before, we have like if the person is having experience in the field of energy will be a plus, or in chemistry that is encouraged, but we are not expecting that to have like a background of physics or chemical. No, all the backgrounds are eligible for these kind of programs, because also this program is designed to not go deeply in each matter and not to say superficially. That means is between. That means we are aiming to prepare leaders that they are going to work in this field of hydrogen. This is the main aim of this program.
Okay. What are the main challenges and barriers that need to be overcome for the widespread adoption and implementation of green hydrogen as an alternative energy source?
The main challenges, as I explained before, to develop green hydrogen, the main challenges that we have is the source of energy. That means a part of developing renewable energy, we should decrease the cost of the production of electricity, localize cost of electricity as much as possible to be competitive to produce green hydrogen at lower price. This is the first thing. The second thing is about desalination of the water, seawater, because we cannot use the water that we have now because there is a conflict with agriculture and potable drinkable water. That means we need to develop this one. After that is to decrease the cost of the electrolyzers. That means we should reduce the quantity of noble metals that we are using. This one important thing for as challenge for this economy. Second one is the transportation, because even that we are producing hydrogen here in Morocco, who is going to pay the cost of construction constructing pipelines from here to Europe? That means also this can be a challenge, but we can have some mitigation plan, like using ammonia as medium to transport hydrogen from Morocco worldwide. These like other alternative, but we have lots of kind of challenges. But of course, for all of these challenges, we have a mitigation plan. And I think the main challenge we still have in green hydrogen economy is to decrease the cost as much as possible. These are very important aspects.
Okay. Quel sera le nombre de participants dans ce master?
Quel sera le nombre
de participants?
This is because here at the university we have some standards. That means for each cohort we have a number of participants. That means for each cohort we should have like a very specific number of participants. But of course, if there are lots of needs, in this case we are also thinking to open 2 cohorts or to open even 3 cohorts to answer to this need that we have nowadays. That was showing even by the participation of in this webinar, or also the people already contact us regarding this master. But of course, we are open to open more cohort than the expected that as expected in the beginning to open just one.
Okay. Pour les candidats qui ont un master privé obtenu en formation continue, les week-ends peuvent participer à ce master. Est-ce qu'ils peuvent participer à ce master?
This is something that we are still thinking about it, because normally we are fixing to have like 1 week, but maybe in the future also we are thinking to have like a master or course that can just running in the weekends. But for the moment, the core that is designed now to have like a formation in 1 week, entire week, not the weekend. But in the future, if we have lots of people that show interest that they want to participate in this master in the weekends, we can design other cohort that can be performed in the weekends.
Okay. For a candidate who has private bachelor's gates by weekly time can apply for this master.
Please, if you can repeat.
For candidate who has private bachelor's gates by weekly time can apply for these masters.
Yes, yes, of course.
Yes.
Mm-hmm.
Of course. How much time a cohort?
The court, as I explained, the court will have each court. We have a specific number of the participation or that can participate on it, and for the time, if I understand well, that the time for the entire masters, the entire master normally is master that is 8 modules. That means can be in 1 year and a half. In total to get the diploma, but we are trying to fix the models in 1 year. Why? Because we want to repeat it each year. That means in 1 entire year, if we start in October, in September we should finish the master, and for each model normally will be a 1 week in a month. This is like the design that we have now for this first course.
Je pense qu'on a fait le tour. Merci beaucoup pour vos interventions. Merci, cher professeur. Peut-être qu'il y a d'autres questions. How much time a cohort? Is it an entire week?
It is not entire weeks. We have 4 days for each model. That means from Monday to Thursday, or can be also from Tuesday to Friday. This is like the core that we are thinking about. And in case that we have 2 courses, just to guarantee that we'll have the same expert for 2 courses, one can start Monday, other one will start on Tuesday. This is what we are thinking. Are 4 days in the week, not the entire week.
Okay. The first round of applications will commence this September, I assume.
They already did start. You can just go to the website that we are going to send you, and you can look there that you can apply from now. You're welcome, Sheikh Al-Kabir. Thank you very much.
Thank you, Professor, for your thorough presentation.
Merci beaucoup. Fees of the master, this question we answered before. This is just write email to the person in charge of the existing master, and they will answer to your question, and even that can even speak by phone with them or via video conferences. Yes, presentation, we will share it with you. We will share it with you. After this meeting, I will just send it to Kautar. She will take in charge to forward it to all the person that participate with us.
All right, yes. Nous sommes là pour répondre à l'ensemble de vos questions. Je pense qu'on a fait le tour. J'espère que ça a été très enrichissant et intéressant pour vous. N'hésitez pas à revenir vers nous si jamais vous avez d'autres questions. Vous disposez déjà de notre adresse mail. Comme ça, on vous répond très rapidement. Dans tous les cas, on va vous partager le replay du webinaire. Comme ça, pour ceux qui ont raté une partie ou la totalité du webinaire peuvent le consulter par la suite. Et merci d'avoir assisté à ce webinaire jusqu'à la fin. J'espère que ça a été très enrichissant et intéressant pour vous. Je remercie vivement Monsieur Samad pour ce partage riche. Ce fut vraiment un plaisir de vous avoir aujourd'hui parmi nous. Et comme j'ai déjà mentionné, nous allons publier ce webinaire, donc ne vous inquiétez pas. Pour ceux qui ont raté une partie ou la totalité peuvent le consulter par la suite. Et je pense que c'est tout. Merci beaucoup et à très bientôt. Thank you so much.
Merci beaucoup. À très bientôt. Au revoir.
Merci, au revoir.
Merci, au revoir.